For these notes, you will need your unit circle. So if you do not have that out, I would pause this video and then go ahead and pull that out so that you can utilize it along with these problems. All right, so assuming we have our unit circles handy, I'm going to go ahead and start graphing sine and cosine. We're just going to talk about the parent functions in this video, and then over the next couple of days, we'll be transforming these in different ways here. The first problem says we're going to be graphing sine of x, y equals sine of x. We're going to first fill in the table with our parent values for the sine function. Now, in order to do this, we're going to use x, these x values, as our thetas, and we're going to evaluate using our unit circle. So for the first problem, I'm doing sine of 0. Now, think back to our unit circle. Sine was always the y coordinates. So sine, if I go to a theta of 0, would be here. The y coordinate would be 0. So I'm going to fill that in as the sine of 0 is 0. The sine of pi over 2, I go to pi over 2. Again, sine is my y coordinate. So I'm going to fill in 1. Sine of pi, I go to pi. Y coordinate would be 0 once again. Sine of 3 pi over 2, I'm down here at negative 1. Again, that was down here at negative 1. And then the sine of 2 pi, I'm back around to 2 pi. Y value would be 0. All right, I'm going to pause here and have you pause as well. See if you can fill in the cosine table down here, remembering that cosine is all of your x values. All right, so if you filled these in correctly, cosine of 0 would be its x value of 1. Pi over 2 would be 0. Pi would be negative 1. 3 pi over 2 would be 0. And 2 pi would be 1. So you can check your answers there. All right, we're now going to take this table and treat it like an XY chart. So each of these are going to be the x coordinates for our inputs along our x-axis. Each of these are going to be the y coordinates for our outputs. So I'm first going to plot these points 0 and 1, or excuse me, 0 and 0. So 0, 0 would be right there at the origin. All right, next I'm going to plot pi over 2 and 1. Now we have the tick marks along here. This tick mark is labeled pi, which means that halfway between 0 and pi would be pi over 2. And I need a y coordinate of 1, so I'm going to go up to 1. Next is pi and 0, so I'm going to plot that. 3 pi over 2 and negative 1. Now 3 pi over 2 is going to be halfway between 0 and 2 pi. Remember that another name is 1.5 pi, which will be halfway between 1 and 2. So that's going to be this tick mark. I'm going to be down here at negative 1, and I kind of need to squeeze that point in where I labeled, and then 2 pi and 0. So this marks one full cycle of the sine graph. Now, let's say I wanted to extend this out if I went to 3 pi and 4 pi. Well, if you think about how this relates to the unit circle, if I were to go to, say, 4 pi on my unit circle, that would be right back. Here's 2 pi. Here would be 3 pi. Here would be 4 pi. I'd be right back here at the same spot with this same y value. So I'd be right back there at 0. If I were at 3 pi, it would correspond with pi and be right there at 0 as well. And in between 2 pi and 3 pi would be right here. And it would have a y value of 1. In between 3 pi and 4 pi would be right here, halfway between, so it would have a y value of negative 1. Essentially, the cycle just repeats itself, and this would keep going and repeating this kind of wave pattern in both directions, right? Because I could go the negative direction, I could go the negative direction around here, and it would still utilize those same points. So we would say this is the first cycle of the sine graph. This is a whole second cycle of the sine graph. Now let's talk about some of the features of the graph here, because we say that this is the first cycle, the length of how long it takes to repeat itself, or the period from when it starts to when it ends, we would say the period is 2 pi before it starts repeating itself and doing another cycle. Amplitude is like the height of the graph. So how far it is from the this midline in here, right in the middle of the graph, to its highest point or to its lowest point. And that midline also has a special name. It's called the sinusoidal axis. So I'm going to mark that with one color here. This is my sinusoidal axis. This is my amplitude here in all of those spots. Now I've defined it formally up here as 1/2 the distance